Osram Opto Semiconductors is one of the innovation leaders in the optical semiconductor sector. This Osram subsidiary develops and manufactures high-power light-emitting diodes, better known as LEDs, and also infrared diodes, semiconductor lasers, and detectors for a wide variety of applications. The chip is the heart of an LED. It is built up from different semiconductor layers and also contains the PN junction in which the light is generated. Depending on which semiconductor materials are used during manufacture, the LED emits either infrared radiation or visible light in blue, green, red, yellow, or orange. At Osram Opto Semiconductors, the semiconductor chips are produced in the clean rooms at the headquarters in Regensburg, Germany, in Penang, Malaysia, and at a later date also in Kulim, Malaysia. The processes used are those originally developed for the fabrication of silicon chips, and they are largely automated. Single crystal substrates are the starting material for fabricating chips. The layer structures needed for the light-emitting diodes are deposited on these substrate wafers under controlled conditions. This takes place in an epitaxy reactor, where the substrates are heated and then gaseous substances are introduced into the reactor. Metallized wafers are now passed on to the photolithography process for structuring. As in a classic photographic lab, all the work done here is under yellow light, because the wafers go through light-sensitive processes. The original substrate can now be removed. This takes place in the laser liftoff apparatus. A high-energy laser beam penetrates the wafer as far as the gallium nitride layer and decomposes it so that the substrate can be removed. In thin-film technology, the surface of the chip is roughened so that the light generated in the diode can be efficiently extracted. Surface roughening is achieved by wet chemical etching. A passivation layer is then applied, which protects the surface from external environmental factors such as moisture. There are now several tens of thousands of tiny chips on a wafer, but they are still joined together in a compound structure. A carrier film is then applied to the wafer. A laser beam is now used to separate the individual chips from one another. The electrical and optical properties of each and every chip are checked in the Quality Control Department of Osram Opto Semiconductors. Faulty chips are identified and registered so that they can be discarded. When the chips are mounted in the LED package, the electrical supply is connected to the contact pads on the surface via fine wire. The LED is now complete and ready to be used in a wide variety of applications.